Hello everyone. Uh, Today I'm here to give a short demo on this big data. What are its practices? What exactly is big data? And then where does this Hadoop comes into picture? And then we will see what are the roles of a Hadoop administrator in this. Okay. So let's start with the big data concept. Now this big data, as the word says, there is something big, right? So what is big over here is the data. Okay. Now what we are experiencing today is huge amount of data getting generated from all the sources. Okay, so be it internet or the smartphones or the sensors, right? So everybody is generating a lot of data, and that's the reason why the digital content of the universe, it's getting almost doubled in every year. It's getting doubled. Okay, we have added almost 90% of the data in the last 2 years. So there is an exponential rise in the total volume of the data that we have. If you look into this slide, it says what happens in just a minute. So we generate 98,000 tweets, more than 695,000 status updates in the Facebook, lots of millions of the instant messages that are sent. And so this means there are a lot of volume of the data that we are generating in our day-to-day life. Okay, so if we have a lot of data getting generated from a lot of sources, now anybody who is storing them and keeping it for a different purpose, or who wants to deal with this type of data, there it's a big problem for them, because big data is a problem which means that a volume of the data is very huge, which is not at all easy for any enterprise to deal with. And then also there is different variety of the data that is coming into picture. Okay, so if we just look what is this big data, so starting with the volume, we have terabyte, petabyte, yottabyte, zottabyte. So whenever we have volume in this range, this is categorized into a big data volume. Okay, so volume is one part of it, but there is also different variety of the data that it contains. Right, so we see data in the form of different blocks that are written, text, messages, chats, images, videos, logs. Right, so this is a combination of structured, unstructured, semi-structured, everything. Okay, all format of the data. If we combine all of them, so that becomes a big data problem for any enterprise to deal with. So why are we discussing this is because if we have data, we have a lot of value in it. Now the question arises, how can I really find out the value out of the big data? It's like a data mining. I have to mine, I have to process a lot of data, and then to extract out the information and then use it for different business insights. Right, so this all these technologies that we hear about today, like NoSQL databases or Hadoop and all, they are all solutions for the challenges that are coming out of the a new format of the data that we are seeing today. Right, so we'll discuss more what is there in a business to engage in it. Right, so why do we really need to care about big data? So the only reason why a business need to look after that is it gives a lot of edge, or it gives a lot of value addition for anybody who can process a lot of data and can do some sort of analytics on top of that, right? And there are multiple use cases which all the enterprises are looking into today for doing a big data analysis and getting a competitive advantage on top of their competitors, right? So starting with like customer sentiment analysis. So if I can understand my customer well, so I can find out what exactly a customer is looking for. Okay, and then how effectively I am doing my campaigning, how I can target my audience, or how can I target my customers, how can I categorize them into different groups, and then how effective I can do campaigning. Okay, in which area I'm doing good, in which geography, where I need to put more focus on the advertisement. So there are a lot of use cases which is possible only if I can process the data which already I'm collecting. Well, all the business, they are collecting a lot of data, but the real challenge for them is to store them and to process them. Let's take example of Amazon or Flipkart or Facebook, right? So they collect a lot of data. Whatever we do in their website, everything is getting logged in. Okay? And this turns out to be some terabytes of the data every day, right? So if a company like that, they have to go and look into what happened or what is going on in their system. So they need to process some petabytes of the data to find out some sort of analytics which they can use to either perform in a better way or to get more insights into their customers or to find out how their products are doing, what are the top trends. So a lot of things are there for a business to engage in. Now this shows what are all different ways. So if we just categorize some of the use cases, like in terms of growing revenue, it could be like a recommendation engines. So if you buy something out of Amazon or eBay, so they come with a recommendation saying people who buy this also buy this, right? This kind of recommendation. Also, we see recommendations in LinkedIn or Facebook, right? So all this recommendation engine, it needs to process a lot of data before coming up with recommendation, and this needs to be done very quickly, and that's the reason why we have technologies or that which talks about processing a lot of data very quickly. And then reducing the risk, we have fraud detection, fraud prevention, digital security. In terms of improving the operational efficiency, we have multiple use cases like web index and search that Google is doing. Then we have image processing, data pre-processing. So multiple use cases are there for big data, which are of a lot of interest for the business nowadays. So some of the simple use cases from all the sectors or some major sectors are taken up over here. So in the retail, some of the use case for big data could be like what are the customers buying patterns. So if I can find out at what particular time, at what particular geography, what is the tendency of buying of a customer, so that I can always ensure that I don't go out of stock with any product. Right? So how can I do that? Only if I have an ability to store a lot of data, which is a historical data, and if I can process it quickly to find out some insights. Right? And if I can also find out a way to do effective promotion of my discount coupons. I can find out this user will be interested on this product. So let's target this user with the product which to make the discounts more and more effective, to customize it based upon the user's need. Right? So, and then in banking, for fraud prevention and detection, manufacturing, it could be used for to check how the quality is there and what are the bottlenecks in the supply chain. In healthcare, it has got multiple use cases in healthcare. All big hospitals, they are going for big data analytics, and not only for analytics, like their daily or day-to-day work, it depends upon processing a lot of data. So we see hospitals coming up with the gadgets that put on the patient's body, and they want these gadgets to send the health information of the patients directly to the server, which is continuously monitored. Okay, so instead of a nurse visiting and doing a daily checkup, they are just trying to automate everything. So they want to take a very proactive decision. So before somebody coming up and saying there is something wrong, they can on the fly find out based upon the health parameters like the blood pressure, temperature, okay, heartbeats, and also on the fly they can find out there is something wrong, and they can trigger the alert for which can be routed to the particular or the concerned doctor. Okay? And then in the energy sector also we have things like uh, multiple companies who are making use of data analytics, like wind power plant. If like Vestas is one of the wind power plant, if they have to install a new plant at a particular geography, so it's very essential for them to find out how the temperature has been on that particular geography since last 100 years. And based upon that, they can predict what would be the weather condition in the next 20 years, because their output, it depends maximum on the weather conditions like wind velocity, precipitation, dew, humidity. A lot of factors are there, right? So if they can find out or they can do some predictive analysis, so that is only possible if they do some historical analysis, so which definitely involves processing a lot of data. So multiple use cases of big data that we see in the enterprises, in the industries today. And that's the reason why we talk about Hadoop, because wherever there is talk about big data, Hadoop automatically comes up. So what is Hadoop is definitely the first question that needs to be answered. So Hadoop is it's a platform or it's a framework which gives me a platform to process big data. Okay? So let's see how it came into picture. So this started in the year 2002 when Doug Cutting and Mike Capella, they were working on their pet project, which is Nudge. So in the next year, 2003, Google published a paper about Google File System and MapReduce, which talks about parallel processing of the data across multiple computers. So Doug Cutting got inspired by these concepts, and he tried to use a similar thing in his Nudge project. And using the MapReduce concept, he got very good result out of this. Then in the year 2006, Yahoo hired Doug Cutting, and with the help of Yahoo, Doug Cutting was able to come up with the fastest sort of 1 terabyte of data. So he was able to sort 1 terabyte of data in 3.5 minutes. And for doing this, he used 910 nodes. So this node is 910 computer running parallelly to achieve this task. Okay? And the same performance, it was improved, right? So 3.5 minutes, it got reduced to some 62 seconds when he increased the number of nodes from 910 to 1460. And then he realized that we can achieve much better performance while processing big data if I can use the power of parallel processing. And then Hadoop came into picture, and now we are ready with the commercial distributions of the Hadoop, which everybody is following up. So what makes Hadoop so special is that this is open source software, so no need of spending a lot of money or huge amount of money on the licensing cost. And second top feature about Hadoop is that it is highly accessible. Okay? So it doesn't require any dedicated hardware or very expensive servers to run this software. It can run on the commodity hardware, which is very cheap, and it can be procured by any enterprise. Okay, so there is no proprietary hardware like in case of Exadata or Teradata or Necteza. So there is no any proprietary expensive servers involved in this. It's like a cheap commodity hardwares on which it can run. And robust architecture is there to have automatic recovery from any failure which can happen. And all these things make a very cost-effective solution for Hadoop, for processing of the big data using Hadoop. So this is how the architecture looks like. We have got Hadoop distributed file system, which is at the bottom there, on top of which there is a YARN framework, And then there are multiple ETL tools, like we have got Uzi, we have got Hive, we have got Pig. So Uzi we have got the workflow, Pig, Hive, data here for the ETL, R is there for the analytics to be done. There is a NoSQL database, which is HBase, and then we have Flume, Scoop, and lot of components are there in this family. And this family is something which is evolving every day. So every month we find something new getting added to this big data family. So what does the component looks like? Let's have a deeper insight into what Hadoop is consist of. So Hadoop is consist of hardware, or now this is a file system which contains the data that we store. Right? So this is a distributed file system which is known as Hadoop distributed file system. And this file system is again broken down into two components, master and the slaves. Now in this figure, it's a main node is a master, and we have got multiple data nodes which act as the slaves. Okay? So over here, this box represents a node which we can just think as a computer which has got both storage as well as processing power. Okay? So this is known as a node, and if you combine all together, it becomes a cluster. And that is what is Hadoop, where it runs on. It runs on the cluster of multiple nodes which can do the work parallelly to get a very fast processing of the data. Then we have a MapReduce layer, which is consist of a job tracker and multiple task trackers. So here also there is a master slave where master is job tracker, and we have multiple slaves which are the task trackers. Okay. This is about the Hadoop components. So how does the workflow happen, right? So we have got multiple slaves, but a user need not really interact with each of the slaves. So if a user or a client wants to get something done or some data to be processed, so the client will just talk to the master, which is a job tracker. Master will take the job, and then it will handle rest of the things, right? So the master will first divide a job into smaller pieces, and each of the pieces will be distributed across the entire cluster, which will be taken up by the task trackers, because we have multiple task trackers, so each of them can run parallelly. And finally, once each of the task tracker perform their individual task, they will be replying, or they will be communicating it back to the job tracker, saying my task is complete. So only once all the task has been completed, job tracker will ensure that the job is finished, and the client will be notified. So let's take one example. Let's say we have a data file which consists of a lot of data which needs to be processed. Right? So Hadoop talks about parallel processing, which means that this data will not be processed as a single file, but it needs to be processed into smaller units which will be running parallelly. So this is how it goes. So the file is getting divided into multiple blocks. So each of the block is going to be taken up by the worker which is in the cluster, and there is a MapReduce phase that goes within the cluster during computation, and whatever is the output that we get as a result or an output of the MapReduce task. Right? So this is an Hadoop overview how Hadoop processes a file. Now coming to the admin part. Now if we have to deal with the clusters or the hardware or the software, so there comes a responsibility of admin as well. Right? So this Hadoop stuff is getting it's divided into two different branches. First one is developer's track, second one is admin track. So developer is responsible for writing the code, writing the ETL scripts, processing the data, writing the MapReduce code, right? And all the things that involve coding and all these things. But since there are a lot of hardware which is involved, there is a need to monitor the cluster, need to expand the cluster, because uh, this cluster, it expands linearly. So if today I got a 5-node cluster, tomorrow if there is a requirement to put 3 more nodes, so there comes a role of an admin. Right? So admin will be responsible for adding about the node or decommissioning of the nodes, and then routine maintenance, recovery, failure. So a lot of things are there, like starting from the installation of this of different softwares, then upgradation, okay, upgradation of individual component or the entire package, and then uh, once installation is done, then some mock testing of each of the component to ensure the cluster is up and running and it's in a healthy condition. Then all the routine maintenance, backup of the data, recovery in case of any failure, or if we are going with any upgrade and it fails, so rollback, okay. So, and if any software needs to be patched up, so that kind of thing. All the performance tuning, configuration, okay, and then all the security, like adding up of new roles or adding up of the users in the cluster, okay, and then a lot of performance tuning which is there, which is done using different configuration parameters in the Hadoop. So these are all the major things which, as a admin, um, the Hadoop admin needs to do or needs to take care. Okay? So during the course, we are going to look into each of the components. Now, we are not going to just start with the admin activities, but we are going to look in detail about what is Hadoop, what are each of the daemon responsible for, where, uh, how is the data getting processed parallelly, okay, how does this architecture looks like, how we are achieving parallelism, okay, how a file is getting read, how a file is getting written, how to handle if in case of any error is there, then how to quickly debug and find out the issue, then how to look for different logs where they are stored and all, and then how to install each of the individual components, what all distributions are there in the market, okay, what are the differences between them, how to do cluster sizing. If somebody says I've got this many terabytes of the data, how many node cluster I want, so how do I come up with the sizing, like what kind of cluster size it would be there, then what are the best practices for deployment of the cluster, then a lot of things are there that we are going to cover during the main classes. So with this, I just end the demo session, and we can hope it was good. So thanks everybody.